Hello, lovely people. We're online. We're online and we're about to get started. Yes, Mike, check in. Good to see you. Get started. Yes, Mike, check in. Mike, check in. Mike, check in. Feel free to leave comments. if you're live, leave comments. Let's know you are watching us live, and it's interesting to have you around. Actually, very excited to have you. It's been a while. We haven't had our usual webinars in a while. I think this is the fifth data science session we are having. I'll be waiting a couple of minutes to get started. I'm hoping to have David online. Yeah, so he can ask me all the difficult questions. But so if you leave comments, we will know you can hear us. And we will know you can see us as well. If you do leave comments, we know you're hanging out there, so we want to see your comments. Yeah, and going onto the screen, share. Just going to have our screen sharing shortly.
Oh, you want?
Yeah.
Oh, you want this?
It's okay. Hi.
Hello,
Hi.
David. Excellent. David, good to see you, my friend.
We are ready. You are welcome to our webinar.
Yeah. Yeah. David, are you take care? Okay. So you have a view of what the comments are, do you? Hello, David. Check in. 1, 2. Oh, good. Okay, I can see comments now. Yeah, good,
Yeah.
good. Okay, so we can get started, can we?
Yeah, let's get started.
Okay, it's very good to be back with the data science webinar series brought to you by Institute of ICT Professionals Ghana. And this one we are focusing on opportunities and retooling for the future. And most of our use cases and examples or explanations will be focused on how your business or your organizations or you as an individual can take advantage of data science for your own benefit or for your business's benefit. My name is Emmanuel Asimadi. I'm your usual presenter, and David, the director of IIPGH, is supporting me with your questions and help me address some of the issues that you might raise in the call. It's good to see you also. If you say hi in the comments, we are happy. I can see Philip, I can see Richard and David yourself. Feel free to ask questions as we go along. We'll be having pauses along the way, so we address all your questions as we go along. For those questions that we are not able to address within the webinar, we will address them and leave useful links for you to review later on, and hopefully we can address all your questions. So let's all have fun. Every question is welcome. Okay, so I have chosen to start it in a bit of an awkward way. Normally you would expect the table of content in the first slide, but here I've just tried to update you on some of the interesting things that have happened in the space since we spoke about 6 months ago. You all may have heard that Google, the company Google, has opened its first artificial intelligence research center in Africa, in Accra. You've also, just from the news last week, almighty Microsoft Azure has a development center, is planning to invest $100 million in 2 development centers in Africa. So you have one in Lagos and one in Kenya, supposedly Nairobi. Microsoft itself has the first data center in Africa, in South Africa. So you see there is a lot of movement in the space. There are 2 interesting things that happen when such things happen. These cloud providers are enablers. When they come into your space, they sort of give you resources for you to do things differently and almost change your business model for something more significant and more interesting. Also, they come along with interesting jobs. And the big question for us is to sort of to ask ourselves whether we are ready for the kind of jobs that these providers bring. The providers bring jobs for their own organizations, but your organization must also position itself to take advantage of the cloud computing services that these providers also provide. Okay, there's also an interesting award-winning blog by Rachel Blankson. She won the World Bank Blog for Dev Award Challenge for 2019, and she poses very interesting ways that individuals can take advantage of the knowledge economy that we are talking about now, that you could decide to freelance on sites like Upwork and now be able to work for any business around the world. All you need is a viable internet service, and then you are good to go. So when you are learning or when you are training, you need to be aware that you are not training for just your local opportunity. You are training for a global opportunity. And that global opportunity means you must be good, or as good, to stand out, you must be good or better than a lot of the population around the world. What is interesting for Ghana and maybe some parts of West Africa is that for Ghana, for example, English is the first language, and English is almost the lingua franca of working. So, and Ghana is also on GMT, so you have a good time you're almost on the right, time zones also count when you are talking of outsourced businesses as well. So Ghana could be an interesting place if we decide to position it right, to receive businesses or export skills to the rest of the world. Okay, and Rachel very nicely captures these things. I think the question we have to ask ourselves as organizations is how we make the internet available to those who need it in an affordable way, and how we skill our workforce or the younger generation on how to take advantage of this interesting stuff. There's also the need to position ourselves as a place that is welcoming of this type of contracts or this type of job opportunities as well. Okay, so we go to what we are expecting to have today. What I'm deeming was cooking. So we'll have a general view of the topic of data science and what makes it interesting. And then I've tailored this to be focused on businesses and what they can gain, or some of the common use cases that are interesting in the domain. We have a view of the landscape, so what is possible even when you are on ground zero, what you can possibly achieve in a stepwise approach. And then I capture opportunities for individuals in the space. And then we talk about interesting topics that are in the space as well. Okay, so the big question and the forever interesting question, what is data science? And this is something we have addressed in our first webinar. It is the simple idea of, or the simple science of deriving value from data. And it is just that simple. We are talking about the tooling, we are talking about the technology, we are talking about the ways in which you can derive value from data. And when we talk about data, the first impression that comes to mind is structured data. This is data in tables, and you have very nice columns and fields, and you can query in a structured way. But the concept or the notion of data is much broader than just tables. We now have text, and because of advancement in technology, these alternative data sources have become equally important and interesting to analyze. So we talk of areas like text, which is a data source in itself. So when we talk of text, you can already imagine that social media is giving us a significant volume of text. You can talk about news, you can talk about blogs. And one example of text that we tend to ignore is what you search online. For example, when you enter a search string into Google, that is also a form of text. And the concept of searching or information retrieval has become even more important now because there's so much text around. If we don't optimize the way you search for stuff, you end up not being able to find the information you need. Now we look at images as well. Images are also become very interesting source of data. So you have your pictures on Facebook and all those interesting stuff on Twitter, on the social media platforms, Instagram. We now have the capability to extract meaningful information from these images. So images are also interesting data sources. This also, images find very interesting applications in the health sector as well, where we have scanned images, and then you can have machine learning models predict that the scanned image it is seeing has evidence of cancer or some kind of disease in it. We also have video, and it's interesting for you to know that video is nothing but a sequence of images to a machine learning model. It's just a sequence of images. And so video is images with an additional time dimension. Then you have audio as another source of data. And this all contribute to us having so much data that we need to develop a significant science to be able to analyze the data. And here I capture the important V's. You have the 3 V's that we use to typically describe big data and why we need a significant science, so to say, to be able to work with this data. These V's are the fact that we are generating large volumes of data, and we need systems that are capable of working distributively to cope with this data, okay? We also sometimes need to process this data at high velocity. So we want to take action on decisions on the live flow of data and not wait until the data has cooled off before taking decisions. Some of these data flows are high speed, and they tend, those that are significantly high pace tend to decay very quickly. So the benefit you derive from actioning the data when it arrives is much bigger than when you wait for an hour or two before actioning the data that arrives. So we need systems that can provide insights on live streaming data. We also are dealing with a variety, significant variety of data. So these together become the 3 V's that we work against when we are programming in the field of data science. So I've just illustrated a couple of data sources and how a machine will perceive it. I think this is just a trivial illustration of a tabular data, okay? And this is the basic form of data that we are all used to. Then we have the textual data to the top here. I hope you can see my cursor. You have the textual data here, and one way of representing it is one-hot encoding, where you have your vocabulary at the top, and then to represent a sentence, say sentence 1, you put a 1 where the word exists in the vocabulary. So if we wanted to represent a sentence, the boy is good, this is how we will represent it. And if we wanted to represent the sentence, girl is good, we put ones where there is girl, there is, and then there is good, okay? And this is almost a trivial way of representing data to your model, or using textual data to do stuff like sentiment analysis, information retrieval, like finding entities in a block of text and stuff like that. This falls under the large umbrella of processes we call natural language processing. Then we have image processing, and to the computer, an image is just an n-dimensional array. For this example, this is a 2-dimensional array representing the number 1. Okay, so you can see it's nothing more than numbers. Okay, computers only process numbers. So whatever we do in presenting information to the computer, we need to convert it from its natural form, like an image, into numbers for a computer to process. And like I said before, when you look at an image, it's just a flat representation. Now, a video is just a sequence of images, as you see here, and there's an additional dimension of time. And we have significant capability of processing image as well as processing videos. And we'll see that as we go along. Okay, and what is interesting about the space is that we need to now rethink the way we think about data. And it's very important that we sort of step back and understand that data is no longer a cost center. Some people call it the new gold. And you need to position yourself as a business to exploit your data. And the more you exploit it, the more value you derive from it. Okay, so you could take your data, and one way you can view it is to see it as a differentiator of your business. You actually could monetize your data. You actually could, the simplest form is to even have data as a service. So if you are a traditional custodian of data, like a telecom provider, you should be thinking about anonymizing interesting data sets that you can publish for other businesses to pay and benefit from. And that is something you can actively do and probably generate revenue from your data set. And an interesting data set for a telecom provider, for example, could be the handset, the type of handsets on your network. Okay, and that might be an interesting data set for somebody who is in marketing, or somebody who wants to understand the profile of people in a certain locality. And such people might be willing to pay for this data set. Whereas the telecom provider might just be interested in storing this data. When they decide to view it as an asset that they can monetize, they can now start positioning the data set in a way that other businesses can connect to and benefit from. Then you can see data as a new barrier to entry for your competition. So when you set up your organization right and you are taking full advantage of your data, like the way a company like Amazon does, competition can come in with the same infrastructure and everything you have, but without the data you have, they cannot do the sort of recommendation, the kind of services you are able to provide. They cannot provide the same level of services. In that case, you are actually actively positioning your data in a way that it is a barrier in itself for competition to be able to compete with you. So the more data you have, the bigger the barrier. The more data you have and the actively you are taking advantage of this data, the bigger the barrier you create for your competition. So if you make sure that you are consistently taking advantage of your data, your competition will find it difficult to sort of compete on the grounds that you have more data and you are making good use of your data. Okay, so this is almost like me telling you what you already know. How do we derive value from data? The most basic form is analyzing it. You analyze your data, you are looking for patterns that are interesting, you are looking for trends, you are looking for correlations, and you are looking for answers to your questions in the data set. Okay, that's the basic form of analysis, and this is what we are all familiar with. In this form, you are looking to answer questions like, which is the most valuable customer, or what's the lifetime value of your customer, what's the lifetime value of customers that enter your business through a certain channel, or how many people are going to churn by the end of the year or leave your subscription, for example. So this is just analytical, asking questions, summarizing the data, and finding useful information from the data. Okay. Another way to derive value from data is by connecting the data to different sources. Okay. So you might have internal data in your organization, but when you connect it to a map data, you are able to get new insights about your internal data. When you manage to connect it to external data, you manage to derive new and interesting insights from your data. And this also speaks to businesses that own data. It means that when you start thinking of exposing this data for other businesses to connect to and benefit from, you are also bringing in new revenue for yourself, whilst enabling other businesses to perform in a more efficient and effective way. Now, the third way you can benefit from data is by bringing the processing into real time. So it's fair to say that you can manage to work on data periodically or in batch mode. So at the end of the day, you have a report, or at the end of the week, you have a report, and 2 weeks later, there is a decision on a report you generated a week ago. That is fairly slow. And when you are very comfortable in batch mode, nothing prevents you from going further to bring your processing closer to real time. And when you do that, you sort of take away the long turnaround time to take decisions. You almost can decide that you want to automate the decision that you would have taken you 2 weeks to make, and bring it to real time. And when you do that, things like service downtime significantly improves, because you don't wait for a long time to take action on the downtime of your service. You have processes in place in real time that manage such things. And so this is almost like an incentive to derive more value from data in the way that, in the sense that you look at your current batch processes and ask yourself, could I take down the time I used to take action on this batch process reports? Could I take the time down to almost real time? And you should put an effort into that, because that gives you significant gains. You can also derive value from data by using it, and this is the most interesting aspect of the new form of data science that we talk about, is to be able to use data to make predictions. Okay, so you want to predict some outcome in future. There is also the use case of where you want to use your data to make recommendations to your customers. Okay, so this speaks to areas like customer segmentation, for example, where you segment your customers into interesting groups or groups of similar customers. And then, assuming Emmanuel, that's myself, I have similar traits to David, it means that when I consume something that David hasn't consumed, but because of our similarity, you can now recommend what I have consumed to David. And this speaks to upselling your product. This also is used, the concept of recommendation is also used in social media to recommend friends to you. So we look at the sort of network you have and see that because you have these people in common, you are likely to be friends with somebody whom I am a friend with, but David is not a friend with. And there are more ways you can derive value from data. These are just a few basic examples. And to summarize what I have just said, there is this spectrum that we use to gauge our data analytics maturity. The first phase is just the reporting phase, as being able to capture the data, have the summary of the data, and try to answer the question, what happened? That's the descriptive phase. The second phase is what we call the diagnostic phase, where we are looking to understand why it happened. So you are looking at business intelligence systems, you are looking at correlation, whether somebody's age is correlated to their height, so that when the person is older, they tend to be taller, or some of these trivial things. So you look at variables and their correlation so that you decide whether something is causing an outcome that you are interested in. You also try to create your own hypothesis and use your data to test whether those hypotheses are valid or not. All that happens in the diagnostic phase, okay? And when you move on this chart from your left to your right, you are having increasing complexity, and with that increasing complexity, we are getting more value, okay? So the third item is you being able to predict the future given the past. Okay, so this block seeks to answer the question, what will happen next? Now, if you are able to tell with some kind of accuracy, some degree of accuracy, what will happen next, it means you can prepare for what will happen next. Okay, a typical example is in churn prediction, or predicting that a certain type of customer will not renew your subscription. Okay, now if you are able to establish that customer A, B, C are very likely to churn, it means your retention program can now focus on just customer A, B, and C, rather than using a broad brush to try to throw gifts at people who are not going to churn anyway. Okay, so those are some of the value propositions for being able to tell the future. If you are able to predict the future, you can dimension to accommodate whatever happens in future. You can plan more effectively to handle issues in the future. Okay, then we go to the prescriptive place where you are almost like trying to automate the decisions that you you ordinarily make as a human when you analyze information. Okay, so in this space, we are trying to answer the question, what should I do? In this space, you have things like linear programming, where you look at giving these constraints A, B, C, D, what is the best path or what is the best set of variable to give me the best outcome in this set of constraints. So this speaks to a lot of automation. And I, this is the sweet spot. This is where you want to be. When you have done everything, you want your systems to automatically decide what is the best way to go. Okay, now we go to the interesting part, which is the applications of some of these concepts in businesses, some of the use cases that we want to speak to. I'll pause here just in case you have any question. Are there any questions? Lovely people. This is just a few minute pause, just in case you have any interesting question. Okay, so I will just continue. In case you have any question, you remember that you can leave your questions in the comments, and we have a view of the comments. We'll address the questions as we go along. Okay, so lovely. These are the interesting things happening in the space, and I think there are even more interesting stuff, but these are the ones that are quite obvious and you see them all the time. So what are some of the applications or the use cases of this predictive layer or the whole concept of machine learning and stuff? What are some of the use cases that we already see value from for our businesses? One of them is anomaly detection. So an anomaly is something that does not belong to the group. If you so you will find you in security, for example, we try to isolate suspicious transactions using such mechanisms of anomaly detection. You can also find it in financial sector where banks want to isolate fraudulent transactions and all and stuff like that. So these are typical attacks where you are trying to cluster transactions or trying to cluster records and sort of decide those that are suspicious so that you can take quick action on those ones. It can be cluster, it can be in a form of clustering, or it could be in the form of finding outliers. Okay, and the typical approach that businesses use to this is that because machines are quicker and faster in finding patterns, they use machine learning approaches to sort of isolate what they suspect to be fraudulent transactions and have experts in the domain sort of look at the isolated cases and take a decision whether they are actually fraudulent transactions. And that makes more effective use of the time of the expert because they don't have to look at all the data sets to find out which ones are fraudulent. They just need to focus on the small subset that may be suspicious. And this is just an example of where humans and machines can sit together and work nicely together. Okay. We also have the concept of churn prediction, where you try to predict whether a customer is likely to leave you at the end of their subscription. And when you build models that are very accurate in your business that can predict churn, it means that when you are working on your retention campaigns, you almost focus the resources on the people who are very likely to churn and are most valuable to your customer base. For example, we have the concept of recommenders, where you we see it at play in different industries. In the movie industry, when you watch an action movie, you are likely to be recommended another action movie. When you purchase an item online, like on Amazon, you sometimes see that basic recommendation that says people who bought A also bought B. So do you want to buy them together and save money? And so some of them are quite interesting recommendations because you want to sort of buy a mower, and then you are recommended an extension board, which you would not ordinarily think of, but you might find it interesting to buy as well. So you end up buying the two. The the model has succeeded in giving money to the producer, and has also solved your problem of knowing what you need to buy together to achieve your goal as a customer. You also have what we call predictive maintenance. So in this case, you have vehicles or equipment in the field. We no longer want to maintain them because it is the end of the month, or it is on a specific schedule, whether we need to maintain or not maintain it. Okay, we want to maintain it when we know that it actually requires maintenance. At this point, if we don't maintain it, it is likely to go off. So we sort of maintain based on the predicted notion that it needs maintenance. And that is more effective and can be cost saving as well. And the big brother of all this you could see is image recognition. The application of image recognition is all over the place. You have facial recognition. The police in other countries like the UK have decided to use facial recognition to identify criminals in the crowd or in public places. These things have privacy concerns, but it's just the sort of questions that will be coming up when we are applying machine learning and stuff like this in public domains. But you will hear of this in advanced countries where they are using such technology for policing, for example. You have image recognition applications in healthcare, where, like I said, you use image recognition to identify that an image or a scan is likely to have cancerous cells in it. Other application that Google has spoken about is the fact that they use the image of the eye to predict a patient's likelihood of a heart attack. Two separately unrelated organs, but you can tell that if we can use the image of an eye to tell your likelihood of getting a heart attack, we are in a good place because it's less intrusive. Okay. And then another application of image recognition, if I'll come down to our context, would be to say that, for example, Ghana Police Service or the MTTU, the Road and Transport Management Service, have cameras at all significant junctions in Accra. Okay, they could decide that this data they are collecting of vehicles, they want to publish it for other businesses to use. Okay, and they can very well anonymize it. And this could be as simple as the timestamp and then the count of vehicles that pass a certain junction, for example. And such data would be very interesting to somebody who wants to market at a certain junction. So a billboard advertiser might be interested in how many cars pass this junction, for which I should pay for advertisement in this junction. And this is data that the police service is likely sitting on and not using for anything. They are using it for policing, all right, but they can repurpose this data for other businesses to use and make money from that data in the process. You could also think of them publishing this data about the make of vehicles that pass the junction at any time. So if I am an advertiser, I want to advertise to people who own Audi, for example, I know that I should do that between 7 and 10 p.m. because that is the point where most Audi cars pass by that junction. Then you have the concept of self-driving cars. This is one of the most significant applications in machine learning or artificial intelligence, where cars are driving themselves without any without any driver. So you have Tesla, you have other even the car hailing services like Uber all have their self-driving car programs internally. Okay, and one of these interesting notions that Elon Musk has put forward is to have a fleet of robot taxis. Okay, so here his concept is that he wants to have a fleet of robot taxis that are driverless, and you can just hail them and they'll come and pick you to your destination. Now, when you own, and he thinks that he can bring this up next year in some regions in the United States or in the developed world. He says that when you own an Uber, you can decide to put it as, sorry, when you own a Tesla, when you own a Tesla, you can decide to put it as part of the Tesla taxi fleet. Okay, so this taxi will drive you to work, and when you are working, you put it in the fleet, and it will go and be a taxi, a driverless taxi in the Tesla fleet. And then when you close from work, the car will drive itself to pick you and take you to your house or wherever you want to go. And you see that significantly changes the utilization of your vehicle, and the fact that once you own a car, you can also make money from renting the car as part of the Tesla fleet. Then we have the area of natural language processing, where you are trying to, machines are trying to cope with human language and text. Okay, and this is very difficult for machines, but there are significant progress in helping machines to be able to do things like sentiment analysis, identifying entities within a block of text and stuff like that. And then you have the concept of translation. So when you speak to your Siri, that's the concept of, sorry, transcription. So you speak to your Siri or you speak to Google Assistant, it's able to understand what you are saying, it's able to transcribe it into text. You can also translate directly from English into French or into German or any other language, so to say. So you have advances in natural language processing making all of this possible. Then you also have the concept of IoT, where we are putting devices wherever we think we want to measure something. So we want to measure temperature, we want to measure particulate data about the atmosphere and see where pollution is and stuff like that. We put devices that can control that, and we have these devices send data to the cloud, and we can take intelligent decisions based on the data from these devices. Okay, so those are excerpts of things that are possible within the broader umbrella of data science. But per industry, you can see some of the things that you can do as per your own industry. So for telecom, for example, you can do fraud detection, you can do churn prediction, you can do recommendation. Problem management is interesting. So this is to say that you have your customer center, and based on what customers are calling in to say, you can almost automatically classify the problem and generate a ticket for a network engineer to solve. So if customers come in from parts of Accra and they are calling in to say that their data is off, you can almost combine it and say that somebody is calling from Abeka, somebody is calling from Achimota, somebody is calling from this place. So the fault is in a centralized location, and you generate a ticket based on customer reports that this is the specific node that needs to be worked on. Okay, that almost eliminates your time for troubleshooting, or sort of minimizes your time for troubleshooting and your time to take action. And that makes a big difference. So we can almost, to a certain extent, automate how we process tickets or send tickets into which buckets they need to be actioned. Then we have telecoms being a significant data custodian, needs to start thinking of ways it can publish its data so that people can access it as proxy data for their different industries. Okay, so I am a marketer and I want to know the age demographic of people visiting the mall. I should be able to access it via a published anonymous data set from the telecom industry, and I want to be able to pay for it and have it. That is a significant new revenue stream that businesses can take advantage of. You just have to be cautious of privacy and make sure you are publishing the aggregated data set and you are not publishing any personal identifiable information as part of the data set. And the richness of data in the telecom industry means you can do a lot of such anonymous data sets. An example is the sort of handsets you have, the age demographic of people in a certain area, and so many interesting data sets. You just have to figure out the use case you want to serve, structure your data that way, and publish it and market it to the people who might be interested in that kind of data set. Okay, then you have the applications in retail where we have recommendation, you have search, and if you are a retail business and your search optimizations are not strong enough, that could make, especially when you are online, that could make a big difference in the purchase decision. Okay, if I go online and I'm searching for a blue boot and I type blue boot and you give me black, I can decide not to buy and go to another search site that gives me more accurate result and buy. So optimizing your search is a significant and interesting science that you need to be able to take advantage of. Then in retail as well, we do sentiment analysis where we want to see how positively or negatively customers feel towards the brand. And this we can do even in greater detail where we can analyze based on, and we'll show you an example in Google where you can see people talking about different topics and we can associate the sentiment to specific topics in the passage. Then we talk about the very interesting one of a market bucket analysis. Basket. I need water. Market basket analysis, where we analyze the shopping basket of individuals and sort of find what things people buy together. Okay. Now, when we do this, we can rearrange the shop in a way that the things people buy together are usually in close proximity to each other. Another way we can think of using such information is to say that definitely when somebody buys product A, they will buy product B. Okay, so we will not put product A and B at the entrance of the shop, because when we do that, they will just pick product A and B and leave the shop. So we decide that we'll put product A at the beginning of the shop and product B at the end of the shop. So that forces them to walk through the entire shop to get what they want to buy. And by walking through the entire shop, they might get to see some things they don't need but want and end up buying it. And those are interesting, clever ways to use data. We have in transport, we've spoken about self-driving cars. There is also the problem of route optimization. So when you want to go from point A to B, which is the fastest and which is the most economical route to go. When you come into insurance, you are looking at fraudulent claim modeling and stuff like that. In finance as well, we look at strategic decision. I think what might be interesting for us is agriculture. And agriculture is a significant part of the African or the Ghanaian way of life. And it could significantly benefit from such advances as well. So where we almost automate and Microsoft Azure has a model for such kind of things where we almost automate when to water, when to irrigate, and when to apply fertilizers to the farm. Okay, And then we have media applications. So you would think that this is IT, this is technology, and the media may be a bit distant from it, but media houses have significant applications for this as well. So one of them is personalizing content. So for a web portal like City News, I want to be able to go on City News, and then the content it presents to me is personalized to me because I have read an article on politics. So it can present to me more articles on politics, or because I've read an article on or an opinion piece, it can present more related opinion pieces to me to read. There is also the area where a media house like the Daily Mail, if I remember right, in the US, uses machine learning to predict the possibility of a story going viral. Now, when they are able to predict that the story would go viral within the first hour of its publication, they know where to place it on their portal so that they maximize their gain from online advertisement. Then you have other concepts of text analytics where you want the media house to be able to analyze text in a way that they can retrieve information from such unstructured source as textual data, and also be able to serve more accurate search results when you go on the portal and you search for a certain specific item. They should be able to service you with the right information, and you want that quickly. Okay, I'm assuming if you have questions, you will stop me and ask the questions. So to backing away from all these interesting use cases, to be able to achieve what you want to achieve, you sort of have to, you have challenges to overcome, particularly when your organization is not traditionally data driven or to say machine learning or artificially intelligent. You have significant milestones to sort of look at and work towards achieving. So the first one is to think about your data. The data is the raw material for all the beautiful things we have spoken about. So if you don't have the data, you even don't have the basis to get started. So your data is one of those things that you need to look at. You have the right inventory of the data. The data should be in the right format that will be useful to business decision makers or to your models that you intend to use. Then you come to the infrastructure. You can understand that the sort of use cases we have spoken to are not trivial. Okay, if you are an organization that has been using data in the past, you even realize that even being able to be in the descriptive layer of things, where you are just collecting data and reporting data, is not easy. So you are coming from the data warehouse, business intelligence solutions background. That in itself is not easy. But now we are looking at infrastructure that should allow you to process data in real time. Okay, we are looking at infrastructure that can put in machine learning capabilities into your data processing pipeline. We are looking at an infrastructure that can analyze significant volumes of data and connect to different data sources, whether it is structured data, whether it is text, or whether it is semi-structured data. So that infrastructure may not be trivial. Okay, so thinking about infrastructure, you are looking at how you'll be able to collect this data and bring it to people in the organization that need to use the data at the time they need to use it. And these people could be business analysts. These people could be advanced data scientists who are modeling the data and doing complex stuff with the data. These people could be people who are helping the executives visualize the data and take important decisions on the data. You can't forget the people, and that is where individuals like us come in, where you as an individual, if you are interested in the field, you have to keep upskilling yourself because the technologies. Someone told me that the technology's half-life is quite fast. So you have to keep reskilling yourself and always updating yourself to stay abreast with the domain. So as an individual, you need to scale yourself, and as a company, your organization needs to be aware of these things. So if I'm in telecom, I don't need to be technical to know that I can do chain analysis or I can do recommendation. Even the doctor who is significantly a literary subject, you as a medical professional, you also need to understand the possibilities in your space. So a doctor with a know-how that data science can benefit them in future would be a more effective doctor than a doctor who is just purely a medical doctor, for example. Then we have the problem of demonstrating business case. Data science is one of those areas where you can find it difficult to demonstrate the business value of what you want to do until you have done it. It's almost like a chicken and egg situation. I guess you have a question. We have the problem of demonstrating benefits. Data science is one of those areas where you can find it difficult to demonstrate the business value of what you want to do until you have done it. It's almost like a I'll keep going. Hello, David. I'm getting an echo. Okay, so and then you have. I hope you can still hear me.
Hello?
Okay, and then
Okay,
you have
can
the
you hear me?
area of project management. So a lot of these data
Can you hear me?
are likely to fail if you don't know the outcome or you didn't have the business case clearly figured out. The challenge with project management for data science is the fact that the domain is empirical and sometimes tends to be exploratory. Okay, so you can end up exploring and keeping exploring until there is nothing to explore without delivering value. And that is what you have to be cautious about. Good. So there's the bigger question of how do I bring machine learning or artificial intelligence into my apps or into my organization? The first and the simplest way is for you, and this is significant machine learning or artificial intelligence into your organization on app. The first and interesting way, and what I call the least effort, is to consume services from the cloud providers. Okay, and I'll show you in a short while what these services are. So they have built their own models for common use cases, and you can just consume these services and then use them in your app, or consume these APIs and bring them into your data workflow internally. And this is interesting. You don't need to do anything. You don't need to care about the model behind it. You just consume the services. The second, which is a bit more involved, is what we call auto ML, where you only need to bring labeled data that has the output that you desire in it. Okay, and then present this data to the system. And this is available on Google. This is available in Azure, and this is also available in the open source library like Keras. And I think there will be other areas where you find things like this. You just present your data, and the system itself chooses the best model for your data. It also does the featureization of your data for you. So you don't do much. You just need to create the workflow and bring the data that is labeled for the system to learn from and use in the prediction of future outcomes. And then from there, you go into what we call a more involved one, which we call transfer learning. And transfer learning, and which we find a lot in deep learning applications, you have very big and well-trained models on image analysis, and you almost piggyback off those well-trained models and use it to do your specific use case. So the typical trivial example in this case is to use the model trained on ImageNet and then use that to sort of classify cat or dog images, for example. And it's an interesting hello world application people use. Then the final and the most intensive one is where you do everything by yourself. Okay, so you end up building your own model from scratch and using your own data. That is a case where you know your use case cannot be adapted to any other existing model. So you have to build it from ground up. Okay, and this is more involved, and this is interesting for people who want to do advanced significant stuff. And I think that when you are using the services layer, you need to be, it's a quick way of knowing what is possible in the domain. And then when it gives you your MVP to start with. And then when you go further down the line and you see that it is not serving your need, then you can start thinking of building your own models and doing stuff on your own. Okay. And this is an example of the machine learning services that are available for Google, for example. So Google classifies their machine learning services into vision, language, and conversation. So you see the individual services you can consume when you are on Google. I know I've run out of time, and it happens all the time when things get interesting. But when you click, when we click on this, we can go to Google's machine learning API. So this is Google's language. This is taking us into Google's language console, and we can almost demo that API, which is the natural language API, to see what it does. Okay, so when I click analyze, I tell it I'm not a bot. And then you can all of a sudden see the output. And I will not dwell too much on it, but you will see the sort of output that becomes available. It's able to tell you that the name Google, which is #1 here, is an organization. Android is a consumer group. And then it sort of does named entity recognition for you. So if you are a business interested in stuff like this is a place to be. It also does sentiment analysis and can tell you the sentiment against the entities in your body of text. Okay, so if I decided to change this to David is great. Sorry for the spelling of the name. And analyze it. It says David is a person. Okay, and it is 100% sure of that. And then you have the concept that sentiment analysis, oh, That's interesting. But the sentiment analysis is good. It thinks that it is positive on a scale of 0 to 1. It is 8. That's 80% kind of positive. But I was expecting it to associate a significant positive score to the person David, which it did not do. So you see, there is room for improvement. There is room for improvement for even uh, uh, significant machine learning capabilities of Google itself. Okay, so when we get back to the slide, hello, David, can you mute your mic? So when we get back to our slide, I hope my mic is muted. I think I'm seeing someone saying, well, working well for me. Okay. So David, in case you have your mic on, you can mute it. Okay, so that's for Google. There are services. Azure also has its own version of the ML services. So Microsoft Azure Cognitive Services, they have recommendation engines, they have speech, they have language, they have vision, and they have search. And these are services and APIs in the cloud that you can connect to and bring into your workflows or into your apps. Okay. And what is even interesting is that even when your organization is not that advanced, you can bring these services into your spreadsheet. So Microsoft Azure, for instance, you can build your own web service on the Azure cloud and call it from your spreadsheet. So in Google, if you check online, you will see a case where someone is literally translating text from one language into another in a spreadsheet by calling Google's Translate API. So you sometimes don't need significant infrastructure to begin to try out or do proof of concepts around some of these things. You just need to Google a bit and see that, okay, I have this web service somewhere and I can call it even in Excel to see whether the field of what I have in mind works well for me. Okay, and then this is AutoML, where you provide label data, and the system finds the best model for you. And some of these things are quite intuitive. If you take Azure, for example, its machine learning service platform is just a workflow. We can think of it as a workflow orchestrator, and it's just drag and drop, and then you build your model, and then you can sort of publish this model as a web service that you can call anywhere else. Okay, so here I'm highlighting a couple of interesting notebook environments that you can play with: Amazon Sage, Google, and then Kaggle. A lot of free resources there you can work with. Now, as an individual, what are the opportunities available? Elsewhere, and I think this is now coming up in Africa, where we are trying to sort of demonstrate the value of data science. I personally think that if you can demonstrate value, businesses will be willing to pay for it. And these are businesses that are willing to take advantage of this new or significant way of deriving value from data. But it's not easy, it's not difficult to find job postings on LinkedIn which that mention significant salaries for data scientists and data engineers. And it's important to know that if you are good, you find yourself in the right places to sort of help people take advantage of their data and then earn as much money as you can, depending on the use case you are able to work your miracles on. Okay, so and And the future of jobs for me is for those people who are versatile and creative. It means that you you know that what you learn today is just temporary knowledge, and you keep updating yourself and readapting to the changing world. So you have to always be you almost have to be a lifelong learner to keep pace with some of these things because they change very fast. So that is how you have to start thinking about the workplace, because with automation a lot of changes will happen. We expect that jobs will go away, but in the same vein, we expect new jobs to be created. And so individuals will have to be less rigid and tend to be mobile and flexible in the kind of jobs they are interested in or pursue in their career, so to say. Then we think that data literacy will become a fundamental skill, like the way I'm speaking English to you, or the way I use Word, or the way I present to you using beautiful.ais. Data literacy will be a skill that journalists will have, will be a skill that medical professionals will have, will be a skill that a public health nurse, for example, will have. A manager who is not a data scientist will also be aware of the capabilities of data science. Okay, now we go onto the area of, I think that there is a significant question that some of us or a lot of people tend to avoid, that is the scenario in Ghana and in Africa for that matter is significantly different. Okay, and the beginning of that is that we are probably not capturing data, or we are not even capturing it the right way. That's one. And also, such jobs are not necessarily available yet in Africa. But we need to begin to tool ourselves or skill ourselves to be able to take advantage of these jobs as individuals. And when you skill yourself well enough, these forces that take away jobs from Africa are the same forces that bring jobs to the shore. So you just need an internet connection to be able to participate in this. And countries like Ukraine, India, Pakistan, you find a lot of individuals on Upwork that are taking jobs in the USA, in the UK, in Netherlands as freelance developers. And that is a very interesting way to take advantage of the new wave of knowledge, of a knowledge workforce. You don't need to be physically located at where you are working to be able to work. And that is very important shift that the cloud computing paradigm and the paradigm of high-speed internet is enabling for us. So you can be in Ghana and work on a big project that is in the UK, for example, because the machines you need are in the cloud. You can just switch it on, process the data where it is. You don't need to move the data out of UK. You process it and shut down the machines. So such models tend to favor people who don't need, who can't be physically present in the job location. So the significant advantage Ghana has is that it speaks English fluently, and then it's located in the part in the center of the world. So it's almost like a reference point for time. So as politicians, as policymakers, and significant decision makers for Ghana, we need to start positioning Ghana as a place for 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 that knowledge workforce, that people will be willing to outsource their work to be done for them. And I think there are businesses that will be interested and based on cost savings will be willing to outsource their machine learning or data engineering tasks to locations like Ghana for people like young people from the university who have formed a managed service business to run for them. So that is an interesting way to take advantage of this as well. And I think with the establishment of centers by Microsoft and Google, and maybe Amazon might come someday in the future, this model will flesh out nicely, because once you are within these platforms, your skill can be utilized anywhere in the world. Then there is also the question of ethics, where these interesting things are happening, but it can be easily abused. Okay, so I spoke about the concept of facial recognition at some point. In the UK, police services are using facial recognition. So it's sort of, people think that it's infringing on their privacy. In San Francisco, facial recognition is banned. And so you see the fight on ethics could become significant. So these are things we have to be aware of. You could also see places where machine learning capability is enforcing stereotypes that exist in historical data. So as an engineer or as somebody who is modeling, you have to understand how your data can enforce and disadvantage people who have historically been disadvantaged. And so you have to find ways of avoiding that. So you can sort of think of it as you are building a machine learning model that is gender biased. You have to be careful of that. You could end up building a machine learning model that is racial. that is racist, for example. And these are things you have to be aware of when you are doing stuff. Okay, now we go into something that a lot of you find interesting, and that is, how do I get started? I've tried to put together a fairly simple knowledge map on what are the interesting knowledge areas in the domain. Okay, and when you want to get started in the domain, or you want to transition into this domain, or maybe you want to have this domain or this skill set out of interest, nothing stops you from doing that. You only need to have a learning path so that you don't go chasing every knowledge that is put out there, because your brain power is finite. So you have to focus on what you want to learn. So one way is to have a learning path that is dated, and you sort of follow that learning path. On social media, you have significant learning paths that you can work with. Okay, the main areas I have captured here. The main areas I have captured here are language and foundations. Okay, and then I have also captured big data processing. So there are books that might be interesting for you. Then we look at advanced modeling topics, and then when you are conversant with all of these topics, you can now begin to practice. And then in the area of practicing, together with IIPGH, we want to set up that data science community, where we have people who have sort of passed through some kind of foundational curriculum that IIPGH is currently using or doing, work on data that is interesting in the data science community of Ghana that will benefit the public. So you can have people working on public data sets or open data sets to learn stuff from, to gain new skills from this data set, but as well as derive value from this data set to the benefit of the country. And these are people that I generally class as citizen data scientists. So it's almost a full circle, from the basic SQL through knowing what language you want to use for data processing, whether it's Python, R, knowing the fundamental data structures you need to be able to process or manipulate data. And then you go into the area of big data, where you learn Spark. I find Apache Spark very interesting, because within that single environment, you can learn all the things you need to learn about data science. And it's in varying levels of complexity, but it's fairly easy to consume. We also have, worth mentioning, the portal of Kaggle, where you have Kaggle Learn, the machine learning competition platform. It has very interesting, well done, and friendly courses that you can just go through to quickly get a handle of the domain. And then a couple of last slides to finalize. We have the hot topics in the area. So you have the area of artificial intelligence, natural language processing, you have cyber security, you have a lot of noise in the area of blockchain, talking about smart contracts and talking about using tokens to reward people for activities or games they play online and stuff like that. And I think one of the significant game changers is the concept of cloud computing, where you don't own any computer, but you can rent computers to do significant things online. So you can rent computers that you traditionally cannot afford to buy as a business and use it for 1 hour, and it will cost you just £10 or worst case £20, and then you can do significant stuff with it, which was not possible in the past. And we have interesting areas of data visualization, machine learning, and all that. So these are all enabling different kind of jobs: machine learning engineer, data visualization experts, business analysts. You're looking at the data scientists, you're looking at the cyber security experts and stuff like that. So you take the part that is interesting to you and grow yourself into that expertise. And because you are competing on the global level, there is no room for small mind thinking. Because when you talk about global competition, you are talking about providing services that an engineer or somebody in India can provide, somebody in US can provide, somebody in Ukraine can provide, or somebody in Russia. So you need to be an expert in your field to be taken seriously. Okay, now there are other interesting resources I sort of thought I could share with you. The most significant one is, and these are links, so they'll be available at the end of the slide, at the end of the presentation in the YouTube channel. The one I find most interesting is the AWS learning paths. So this is an image of the machine learning engineer learning path. And you see very interesting courses and their level of difficulty if you want to gain this specialty. When you go on this site, you will see the data engineering learning path. You will see the data scientist is transferable to any cloud platform. You just need to know the names of the components and where they belong. Okay? And there are other cloud platform courses on Coursera, EDX, and stuff like that. For those who are looking to be more business facing, you have this interesting book about data science for business by Forrester, I've forgotten the name, where he sort of moves abstract significantly away from the technical dirty details, but still makes reference to them in a nice way that somebody who is business aware can understand how their business can benefit from the growth of data science and stuff like that. Then you have the Kaggle Learn, which has both the knowledge, the data, and the technology platform. Yours is just to come with your internet and log in and start learning and programming against actual data sets. There is this book, which is a Python for Data Science handbook, which is also very interesting for somebody who wants to enter the domain and see what is possible. And I think that these are just a subset of books or resources online that you can take advantage of. The most important thing is that you should be aware that the most important thing is for you to be aware that you should refresh your page in case you have lost the connection. The most important thing is for you to have focus, because the industry is not short of information. There's even too much information for us to sort of use. So you have to have the focus to want to learn and master some domain and start to broaden out into other domains once you master a particular domain. And so that's the end of my presentation. Thank you very much for your attention. And I see there might be a couple of questions that we might want to address. And I'm very much aware I'm 30 minutes above time. So David, in case you have any questions, I'm ready to take up such questions.
Thank you very much, Emmanuel, for this excellent presentation. I hope you all enjoyed it. Thank you very much. Emmanuel, for this excellent 20 professionals who were part of our Python programming lessons, and we'll be going for the third Python details. Please get in touch with me, and I'll share more details with you. Once again, Emmanuel, we are grateful for your time.
Yeah, thank you. Yeah, you're most welcome. And thank you all. I hope you enjoy your weekend. It's been nice sharing some time with you today. I'll look at the questions that are in the chat and address them. But there will surely be a publication on this webinar and the questions and the useful links thereof. Thank you and have a beautiful weekend.